Hello, Algebra 2ers. We are actually moving into Chapter 2, and we're going to be graphing some quadratics. So graphing quadratics. We've been working with linear functions, and it's time to move on to our next function, quadratic function. So let's go ahead and define it for us. So a quadratic function, as a reminder, linear functions had a degree of 1 and made a line, so quadratic functions have degree of 2 and create the shape called a parabola. And we've probably seen them in Algebra 1. We have this kind of U-shaped parabola. So we learned about parent functions earlier today. So our parent function for our quadratic is f of x is equal to x squared, right? This is our base function. That's where we're starting from. And then from here, we kind of shift it around. So let's go ahead and throw this on a set of axes. Hopefully I can fit this in here. Unfortunately, the graphs kind of get a little big as we graph these quadratics, especially this parent one, because I want to start here at what we call, of course, the vertex. All right, so our vertex is at the origin on this one. It doesn't have any shifts. It starts at 0, 0. And then it also doesn't have any stretches or whatnot. So we kind of have this relationship from your vertex where you go over 1, up 1. And then you plot that point. And of course, whatever happens on one side happens on the other because a parabola is folded in half. It's symmetric. So then you go over to up 4. Over 2 up 4. And the other relationship that I want to point out is, of course, over 3 up 9. I just fit it on here. And on the other side for negative 3 up 9. And of course, this would keep going, right? We would have over 4 up 20, or up 16, over 5 up 25. And then you use your pencil and you create a best as you can nice curve all between these points to create this parabola. And parabolas have some vocab that we need to talk about. So this point down here, which happens to be our minimum, if the parabola is flipped over, it's the maximum, is what we called our vertex, right? And your vertex is either your maximum point or your minimum point. I'll throw that on here. It's either your max or your min, because you might want to know that for some word problems. And then we also have this line that goes right through your vertex, and it folds this parabola in half. It makes it symmetric. It happens to be the y-axis here, and that is our axis or line of symmetry, right? Everything that happens on one side also happens on the other. Okay, this is our parent function, but we're definitely going to go ahead and move some things around with it. And we're going to start with this form called vertex form. And make sure you have lots of space here to add things onto this because we're going to add notes as we work with it. So f of x is equal to a times x minus h squared, because it's a parabola or a quadratic, plus k. And this is called vertex form because your vertex starts at this point. So we're going to say vertex is at the point hk. And that's because h is your horizontal shift, as we found out earlier. And k is your vertical shift. Okay, so if we're going ahead and choose a different color here, looking at an example for this, so example 1, we might have a function saying f of x is equal to x minus 3 squared minus 4. And we need to graph it. So I'm going to set up some axes here. It's a nice set of axes. There we go. Okay, so our vertex here is at the point, now be careful, this is positive 3 because it's x minus h, so we want to take kind of the opposite sign of it. So it's a positive 3, but this one's a negative 4. You use the sign for your vertical shift. So we know that our vertex is at the point 3, negative 4. So pretty easy from there, we can plot that point. 2, 3, and then down 4. 1, 2, 3, 4. Now, this parabola does not have a stretch with it yet. We'll get to stretches in just a little bit. So when you don't have a stretch, or when you have a stretch of 1, I want you guys to look at this relationship. Is that from your vertex, you're going to go over 1, up 1, and you're going to go ahead and you're going to plot that point. And then, of course, that same relationship happens on the other side. Over 1, up 1. And then we want to go for the relationship of 2. So over 2, and then up 4, because 2 times 2 is 4. And that's our next relationship. Now, if we still had some room here, we would go over 3, up 9. And that would be our next point that we graphed. We don't have that on this, so we're going to go ahead, we're going to do the best that we can of creating this nice curved line. There we go. Sometimes my iPad will make one for us, which makes it really pretty. And there's our parabola. All right, that's how we graph our quadratic on this one. Now, something that I want to point out on here are these points right here, and these are your roots. We're going to get to this tomorrow, but your roots, of course, can be the solution to your function, but for right now, they're where they cross the x-axis, and these are the points 1, 0, and 5, 0. So just kind of keep that in the back of your mind. Those are your roots. Okay, so that's with your vertex. Now, we're going to go ahead and talk about what happens if this is negative out here. If you notice, I just added it to your, if you're kind of lost on where I added that, there we go, a negative right there. So what happens when that number is negative on the outside? So what this does is it is a reflection over the x-axis. A reflection over the x-axis. As we know, it makes the parabola go upside down. So let's look at another example of that. So we'll say example 2, and we're going to do g of x is equal to now negative x plus 2 squared plus 3. I'm going to go ahead and draw a set of axes here. Give myself plenty of room to work. There we go. Okay, so we know that our vertex is at the point negative 2, 3. I'm going to just say vertex negative 2, 3. So let's start there. There's our vertex. And now we're going to do that relationship. We're going to go over 1, but we're now going to go down 1. And that works in the other way too. Over 1 and down 1. Now, you don't have to draw these things on the yellow. I just wanted to show you these relationships with it. And that still relationships happen. You're going to go over 2, but now you're going to go down 4. Over 2, down 4, and I don't think I'm going to try and do 3. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm all the way down here, at the very edge of these set of axes. And as a good kind of rule of thumb is that you should draw, if you have room on your axes, you should plot those points that you can, as much as you can on those set of axes. And again, do the best that you can with kind of those curves. As you can see there, mine got a little funky. That happens. We do the best that we can. We're not perfect. All right, so that's with a reflection. So what we now need to talk about is what this A does, or what this value up top does. And what I'm talking about is this value right here, that A. And that's what we call our stretch. So I'm going to put this in here, stretch, blue. And it either makes the parabola really skinny, All right, if it's greater than 1 or if it's between 0 and 1, it makes it kind of short and squatty. All right, so I need to scroll down. Use red. So hopefully you are looking at your notes, and we're looking at example 3 here. And for example 3, we're going to do h of x is equal to 2 times x plus 1 squared. All right, and as we notice here, I actually don't, my k is 0, so my vertex is going to be at the point -1, 0. All right, so that one didn't really have that vertical shift. Let's draw a set of axes on this one that we can work with. Okay, so we're starting at this vertex here, -1, 0, but now this stretch, watch this relationship. We're going to go over 1, and normally we go over 1, up 1. Now we're going to go over 1, up 2. We're going to stretch it by the amount of a. And again, over 1, up 2. Okay, now I don't think I gave myself enough room here. Usually we go over 2, up 4. We're now going to go over 2, up 8. 1, 2, 3, 4, 5, 6, 7. Oh, I'm all the way up here. So sorry that we had to go all the way past there. I'm actually going to see if I can move that vertex a little bit. That's okay. And then on the other side too. So I know it's not great on this graph. Sorry about that. But now it would be this really tall, skinny parabola in there. Sorry that I went through there. But I wanted to show you that the relationship is now stretched by 2. Right? So you're stretching by whatever the number is out there. I'm just going to label that stretch. And that's kind of the hardest part of this, is think, what is that number and how does it affect your parabola? Let's talk about one more example here. I'll shift to this, we'll do orange here. Put it down here. So we'll say example 4. We're going to put it all together. So we're going to do j of x is equal to, we're going to have a -3, so it's reflected and stretched, x minus 1 squared, and then add 2. And from here I know that my vertex is at the point 1, 2, and I have a reflection and a stretch. So some things to think about on this one. So I'm going to draw a really big set of axes here, as big as I can. I'm not sure if I'm able to use all of them. There we go. So I'm at 1, 2. I think I can go up from there. We'll start with this, and I'll scroll this up a little bit. All right, so starting with my vertex 1, 2, here's my vertex. I now know I'm going downwards, but I'm going to use this stretch. So I'm going to go over 1, down 3. And of course, you want to plot your point on the other side too. And that next one would actually be over 2, and we normally go down, we would go down 4, but now we're going to stretch it by 3, so we go all the way down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because we have to stretch it by 3. Sorry, it stopped drawing that nice straight line. But we know that this is my next stretch, and over here, and we go ahead and draw our curved lines through it for our parabola. There you go. All right, so very quickly, I just want a little recap here. So some extra notes that you should add on is that if you have a negative inside the parentheses, sorry, we're going to say negative inside the parentheses, this is a reflection over the y axis, so just kind of keep that in mind. And as a reminder, use an input to check your graph. So like plug in a point, make sure it's actually on your graph, and just double check that you have everything correctly. And we didn't get to when A is between 0 and 1, it actually makes the graph shorter. So makes parabola shorter. For example here, if I threw these on a quick set of axes, I think I stayed on one page, just a quick set of axes here, and I just had f of x is equal to 1/2 x squared. We'd start at 0, 0, and then we'd have to go over 1 up a half. Over 2, we normally go over 2 up 4, so we go over 2 up 2, because we cut everything in half. And then we just draw. And as you can see, it kind of makes it short and wider here on that parabola. So just an FYI, if it's between 0 and 1. Okay, very nice job, Algebra 2. I will see you soon.